Everyone, today in this problem we are gonna solve remove nth node from end of the list problem. So in this problem we are given a simple link and we have given a n, and in this problem you can clearly see n equals to 2. That means from end we have to delete this second node. If we delete this, then our list will be like 1 2 3 5. So this is very simple problem. So how we are gonna solve this problem, let's see. We can solve it in a two parts. In first part, what we will do, in first part we will calculate the size. Let's say after calculating the in first part we find the size is 5. Okay, now what we will do, if I have to delete the second node from end, so you can also say that I have to delete 5 minus 2 third. Okay, 5 minus 2 third. You can say from here at the distance of third 3 1 2 3 you have to delete this node. Okay, so rather than, because in list we can iterate in this way only, we can't iterate from end. Okay, so what we will do, first of all we find the size and then we will delete our 5 minus 2 this node. So what does it mean? From here what we will do, we will come here, and after coming here what we will do, we will make this link to this and we will delete this. So let's see how we are solving it. So this int size will calculate the size. So first of all we are taking one variable temp which will start from our head, and then we will calculate our size. After finding the size we will recalculate this n. First of all this n is from nth node from end. Now we are seeing the n from the starting point. Okay, so how we will find size minus n? So we have to delete size minus n plus 1th node. So for that we have to go to size minus nth node. For deleting this node we have to reach here and then change the link. Okay, so I am not adding plus 1. So what I will do, I will go to temp till nth point till 3, and after that if in case, let's say if I say I have to delete my 0th node. Okay, 0th node from end, that means, okay, so if you say if I have to delete this node, okay, so in that case what I will return, in that case I will return this head nest. If our temp is pointing to null, in that case I will return head nest. Otherwise what we will do, in this case I have to make this. So what I will do, my temp is pointing to this, I will first of all store this pointer. Okay, by temp1 will store this pointer. Then I will make this link, temp nest will point to temp nest. Temp nest is this, so this will point to this. After that I will delete this, because we can't just change the link, we must have to delete this also, otherwise there will be a memory leak, because we have created this, we have created 4 but we haven't deleted from the heap, so we must have to delete also. So we will delete it and then return the head. So this is the two parts. In the first pass we calculating the size, in the second part we are deleting the node. So can we solve it in a single pass? Like time complexity is, we can say it is 2n. Okay, and the space complexity, because we are not using any extra space, so it is O1. So can we do it in a single pass? Let's see the second solution for that. So in this solution what we are doing is, we are taking two pointer. Let's say first is one is my fast pointer and one is my slow pointer, and I will move my first pointer by nth step. Okay, let's say if my n is 2. Okay, so what I will do, I will move it 2 pointer by 2 step, that 1 and 2. Now my fast will points to here. Then what I will do, I will make my star slow points to this and move both of them. Right now what is the difference between them? 2, there are 2. So what I will do, I will move my pointer by 1 by 1. So slow will points to here, fast will points to here, then slow will points to here and fast will points to here. As my fast points to the last, where my slow points to, the slow points to the node which we have to delete its previous node. So slow is pointing to this. Now as soon as my fast points to last node, what I have to do is, I have to make this link points to its next and we have to delete this. Okay, so what is the intuition behind that? The intuition is very simple. If this is the n step, okay, in the earlier there is a difference between slow pointer and fast pointer. if n. So at the end of, basically it is n minus 1. Okay, n minus 1 are between them. Okay, so after one f pointing to here, f pointing at the end of the list, so slow points to the nth node before the nth node. Why? Because they are moving at the same speed. Both of them are moving one step, one step. So the distance they have earlier, they have the same distance here. So this is the basic intuition. Now let's check the code. So first of all, we have a slow which is pointing to head. Fast is also pointing to head. First of all, we move our fast pointer by n step. Now, if our fast pointer is pointing to null, that means if I do nth step and my fast is pointing here, in that case, what it means? It means that you have, because we have to delete from end. So what it means? You have to delete the first node, because we have to delete the slowest next point, because right now slow is pointing to head. So in that case, we will delete this point and return this. So in that case, we will return this. Otherwise, if it not pointing to null, it fast is somehow in between here. So what, in that case, what we will do, we will start our slow and fast pointer by one step. Then after, when fast next is null, that means if we are at the last node, if we are at last node, in that case, what we have to do, we have to stop our iteration, and then our time should first of all store the slow nest, and then its slow nest should point to slow nest. That means slow is pointing to here. First of all, we store this, then we make this link. After making this link, we have to delete. Okay, we must have to delete from the heap explicitly. Then we will return our head. So this is a simple solution. It is a single pass solution, and the time complexity will be of n and the space complexity will be of 1, because we are not using any extra space. So if you like this video, please do not forget to hit the like and subscribe button. Thanks for watching.